Hello, welcome to Chapter 4, which is all about congruent triangles. Section 4.1, we're going to be applying the triangle sum properties, but additionally, we're going to learn how to classify triangles by angles and sides. We're going to calculate an exterior angle measure using the exterior angle theorem, and finally, we're going to calculate an interior angle measure using the triangle sum theorem. When you are asked to classify triangles, you're going to have to classify them two ways, by their sides and by their angles. So let's go ahead and define what each of these types of triangles are. A scalene triangle is one that has no congruent sides. Okay, so all three sides are going to have different lengths. An isosceles triangle has at least two congruent sides. And an equilateral triangle is going to have all three congruent sides, or all three sides are congruent. So like I said, when you classify a triangle, you don't just classify by its side lengths, you also have to classify by its angles. So we have four different types here. The first one is a right triangle, and a right triangle is going to have one right angle. So a 90-degree angle, and inside the triangle there's going to be that little box that indicates a right angle. An acute triangle has three acute angles, so all less than 90 but greater than 0. An obtuse triangle is going to have one obtuse angle. And then an equilateral triangle is going to have three congruent angles. So let's take a look here at example 1 and 2. We're going to be classifying the triangle by its sides and its angles. So the first triangle here that we have has side lengths 23, 16, 19. Since none of them are the same, this is a scalene. And then we look to see its angle measurements as a measure of 110 and 20. So because I see that one angle is larger than 90, it's a scalene obtuse, because one of the angles is larger than 90 degrees. All right, example over number 2 over here, I see that it has two side lengths that are both 4, and the third side's not the same, so that makes it isosceles. And then I look at the angles, I see this right angle right here, so it's an isosceles right triangle. For example 3, I'm given the coordinates of a triangle and asked to classify it that way. So the first thing I'm going to do anytime I'm given coordinates in this class in geometry is I'm going to draw the picture, or plot the points that they're asking me to plot. So the first point is at -2, +2. My second point is at 4, 2. And then my third point is at 1, 6. So 3, 4, 5, 6. And again, this is just a rough sketch. It's obviously not going to be perfect because I don't have a piece of graph paper here. So it's nice with these coordinate, if you're trying to prove it in the coordinate plane, it's nice when the segments are horizontal and vertical, because then I could count across and see how long the segment actually is. So if I wanted to get from this point to this point, because it's a horizontal segment, I could count. I'm going over 2 and then another 4. So this segment is 6. To find the other coordinates, I'm going to have to use the distance formula from chapter 1. So I'm going to go ahead quickly and refresh our memory of what the distance formula is. It's x2 minus x1 squared plus, and then y2 minus y1, that quantity being squared. And it's added and underneath the radical. So I'm going to go ahead and find the distance of this segment right here. This is from point 1, 6, that's that top point, and 4, 2 is over here. So big square root, take the x's, 4 minus 1, square it, plus take the y's, subtract them, square that. Let's clean this mess up. We're going to get 3 squared plus -4 squared. That gives me the square root of 9 plus 16, which is the square root of 25, which is 5. All right, so the only thing I know at this point is it is not equilateral for sure. I'm going to do the same for this last side over here, which this third point is -2, 2, because I don't have space on the left side, I'm going to go ahead, draw this arrow to over here. Okay. Now, the length of this side. Take the x's, subtract them, and square that answer, plus take the y values, subtract them, square that answer. So it's going to equal the square root of -3 squared plus -4 squared. Whenever you square a number, whether it's positive or negative, you always get positive. So this is 9 plus 16, which we had earlier, so it is 5. So this is an isosceles triangle. And we will do an example later in these notes to determine whether or not it would be a right triangle, because that's the only thing you could really determine in a coordinate plane is if it's right. Whether it's acute or obtuse, you would kind of have to go based on looks, but in order to prove it, you could only prove a right triangle. All right, let's move on to a little bit of vocabulary that's going to help us with the rest of this section, and it is interior versus exterior angles. So when you have a triangle, it has 3 vertices, so that means it has 3 interior angles. So like this triangle has angle A, B, and angle C. So that shouldn't be anything surprising or confusing to anybody. It has 3 interior angles. Sorry, let me try to straighten out these sides because a little crooked. Okay, now an exterior angle, that is most definitely something that's new. The way you would get an exterior angle, and every triangle has 6 of them, is you take a side and extend it. And then the angle that is formed between that side and the adjacent side, that's an exterior angle. So there's one there, there's one right here. If I use a different color now, if I took this side and extended it, this becomes an exterior angle. So at each vertex there are 2, so there are 6 exterior angles. So every triangle has 3 interior angles and 6 exterior angles. Okay, the Triangle Sum Theorem is something that most kids know. I think you learn this in junior high or whenever you do a little bit of geometry in your math classes. But the Triangle Sum Theorem says that the 3 interior angles of any triangle you could think of, it doesn't matter what how it is classified by its sides or its angles, the interior angles of any triangle have a sum of 180 degrees. Okay, so that's going to bring us to example number 4, which is asking us to find the value of x in each of these following triangles. So we just said that the 3 interior angles of a triangle always add up to 180. So for the first one here, for part A, I know that 62 plus 48 plus x is going to equal 180. So I'm going to add 62 and 48. I get 110. Plus x equals 180. Subtract 110 from both sides. It's going to give me x is equal to 70 degrees. And if you're not sure of your answer, always plug it back in. The 3 angles should add up to 180. All right, part B, a little bit more complicated, but not too much. We have 60 plus 85 plus 2x plus 5 equals 180. Let's combine anything that we can on the right side. So 60 plus 85 plus 5 gives me 150. Plus 2x equals 180. All right, let's subtract 150 from both sides. We're going to be left with 2x equals 30. Divide by 2, x is equal to 15. And again, you can plug that back in to make sure that your 3 angles add up to 180 degrees. All right, for part C, I want you to pause the video, attempt it on your own. I'm going to display the answer only. So yeah, pause the video. Okay, so hopefully you tried that problem on your own and you should have gotten that x is equal to 35. If you got anything different, make sure tomorrow when you're checking your notes or when your teacher's going over the section that you ask about that problem if you did not get that, okay? All right, so the last example on this page is, you may think it's the same as the problems we've done up above, but it's going to lead us to what is called a corollary on the next page. So let's go ahead and solve this example. It says find the value of x, and again we have a triangle, so we just used and applied the fact that all 3 angles add up to 180. So I take angle E, which is 2x, plus angle G, which is x minus 6, plus angle F, which I recognize that symbol means that it's 90 degrees. and it equals 180. So let's combine anything that we can on the right side. Let's clean it up. 2x plus 3x, or I'm sorry, 2x plus x equals 3x. And then a minus 6 plus 90 is going to be plus 84 equals 180. Subtract 84 from both sides. We get 3x equal to 96. X is going to equal 32. So I'm going to go ahead and plug x back into both of these equations. If I plug it into angle E, 2 times 32 would give me 64 degrees. And then if I plug it in for angle G, 32 minus 6 is 26 degrees. So I want you to notice one thing that's going to lead us to the next page. The sum of these angles, if you notice, is 90 degrees. That should make sense because angle F here took up 90 of the total 180 that a triangle's interior angles add up to. So the two leftover angles have to have what's left over from that, which has to be 90 degrees. All right, so this is the corollary. It says that the acute angles of a right triangle, so the two that are less than 90 degrees are, and they are always going to be complementary. Meaning they have a sum of 90 degrees. That brings us to our last theorem of the day, and that's the exterior angle theorem. So remember we talked about exterior angles on the previous page. Every triangle has 6 of them. You get them by, if you look in this picture below, you extend the side of a triangle, and then it is formed by that side and the adjacent side of the triangle. So right there, that 130 degrees would be an exterior angle. Here's how you find its measure. So an exterior angle measure is... So measure exterior angle. It is equal to the sum of the two non-adjacent interior angles. All right, so that's a lot of vocab right there. I'll explain what I mean in this next example. Before I do that, though, I would highly, highly, highly encourage you guys to highlight this, put stars next to it, make it as visible to yourselves as possible, because this is something that gets kind of lost in all the other things that we're going to cover in this chapter, and it is not a difficult thing. Students could do this. The math is not complicated at all, but when it comes time to assessing it, I have found that kids completely forget how to do this. So again, take a highlighter, star it, write to yourself, say study this, something, so that you don't forget, because it's going to be easy points that way too many students are losing because they don't go back and study. All right, so example 5. For each of the following, find the value of x and the measure of any unknown angles. So, like I said previously, that was a lot of words that and definitions that you would have to know, but it says the measure of the exterior angle, which I have here, is 130 degrees. It equals the sum of the two non-adjacent interior angles. This angle right here is adjacent to 130. So the two non-adjacent ones have to be the ones that are away from that angle, not next to it. So 130 in this case is going to equal x plus 4x plus 10. Okay, let's clean up the left side here. So 130 is going to equal 5x plus 10. I'm going to subtract 10 from both sides. You get 120 equals 5x. Divide both sides by 5, and we get 24 is what x equals. Sorry, I ran out of room, so I have to write it, squish it in here. The directions also ask me to find any unknown angles. So this angle, if it's x, it's 24 degrees. And then if I plug it in for angle H, 4 times 24 plus 10 gives me a measure of 106. Remember what was said, the exterior angle, 130, is the sum of the two non-adjacent. So 106 plus 24 should equal 130 if we did that correctly. It does, so we know we did it correctly. All right, 5B, same idea, a little bit more maybe complicated setup. I don't know. I don't think so. I think we could all handle it. Let's go ahead and do it. So the exterior angle, which is 5x plus 12, is equal to the sum of the two non-adjacent, so not next to it, not right next door to it, the sum of those two interior angles. So 5x plus 12 is going to equal 137. Subtract 12 from both sides, and you get 125. So x is going to equal 25. Right, but then I have to find all the unknown angles. So the only unknown angle here, I would do 5 times 25 to get this exterior angle. 5 times 25 is 125 plus 12, 137, which we did say that's what the exterior angles add up to. All right, last one like this. It's telling me to find the measure of JKM. So angle JKM is this exterior angle. So I'm going to use the exterior angle theorem. 2x minus 5 is equal to x plus 70. It's the two non-adjacent interior angles. All right, let's solve this. I'm going to subtract the x from both sides. So I have x minus 5 equals 70. X is going to equal 75. Right, but that's not even what they asked me to find. They asked me to find the measure of angle JKM. So JKM is 2 times 75 minus 5. 2 times 75 is 150. 150 minus 5 is 145 degrees. All right, problem number 7 here. I don't know if you noticed, but I noticed that the scaling is off for it. So I'm going to draw my own coordinate plane for this problem. This is similar to one we did earlier in the notes. I want to say example 3 maybe. But I'm going to draw my coordinate plane. I see all my points are positive. So 1, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's point A. B is at 4, 8. So right up there. And then C is at 2, 1, 2, 3, 4, 5. All right. This is a bummer. There are no vertical or horizontal sides, so I'm going to have to find each side length. So AB, I would do the distance formula like I did earlier, and I want you to take my word for it that it's the square root of 10. Okay, BC, do the distance formula, and you should get that the length of BC is 13. And then AC, you should get that the length is square root of 17. So right off the bat, I know that it's scalene because there are no congruent sides. So scalene triangles have no congruent sides. Notice the directions for this one are slightly different because it says to determine if the triangle is right. We have not done that in the previous example. I promised you it was coming though. So the way that I would do that is to test for slopes, because the only thing I could figure out is if there's a right triangle. How do right triangles get formed? By perpendicular lines. So what I'm going to be looking for is there a right triangle? Whoops. Is there a right triangle here, here, or here? A right angle, I should say. I'm looking for a right angle. So what I have to do is find the slope and see if there's any slopes that are opposite reciprocals from last chapter. So the slope of AB, if I calculated that, I get negative a third. Okay, that doesn't tell me anything. I have to find the slope of BC. So I do y2 minus y1 over x2 minus x1. For all of these, it would be 3/2. And then the slope here is negative 4. So I didn't go through showing you distance formula for this one because we did it previously. I didn't go through showing you how to find the slopes for this one because we spent over a week last chapter doing slopes and lines and equations of lines. So that part you should know how to do. I'm checking now, what do these slopes tell me? Are any of these sides of the triangle perpendicular? No, so this is not a right triangle. I'm not going to say if it's acute or obtuse because I can't do that in a coordinate plane. All I could determine is it right or not? And the way I do that is check if any of the sides are perpendicular. Angles. All right, that brings us to the last page. Did we accomplish the objectives? Can you classify triangles by sides and angles? If yes, great. Can you calculate the exterior angle of a triangle? This is the thing that most kids forget how to do, not because it's difficult. In class, when you're working on it, kids could do it. It's just they forget that theorem when it comes to studying for a quiz or test. So again, highlight, star it, make sure you remember it. Put a bubble around it. I don't know. Something to remember it, please. And then finally, interior angle measures of triangle sum theorem. So that's all the interior angles add up to 180. So those are the 3 things that you should have gotten from this section. These next 2 or 3 examples your teacher will do with you in the beginning of class tomorrow. Thank you so much for watching. Have a great day or evening. Bye.